Okay, so this week I decided I'd go out and drive my robot around and pick some points in the yard so I could create a path and then go run it on the try to get the first I could run it on the simulator if I really wanted to, and then I could take my vehicle out and say drive to this path and keep everybody happy. So let me change my view here. Okay, so I went out to do that, and in order to do that, I had to get my GPS correction data working. And to reiterate, over the last several months, I was saying I can still use my ESP32 board, which connects to my home Wi-Fi and squirts correction data right into my GPS receiver. But that only works if I'm in my front yard, and I could put like some kind of a Wi-Fi out in my front yard and then possibly drive around anywhere I want. And the next option is those telemetry radios that I was talking about a couple of weeks ago, maybe as much as a month ago. I could set those up and get that to work, or I have my cell phone. I was able to get my cell phone to get correction data. I went out to the Argue Simple website, and they've got something called oh, no, I forgot what it's called, GNSS corrections or something like that. It's just an app you load onto your cell phone, and then it gives you the option of connecting to an in-trip server over the internet, or getting various kinds of information. But it does what I need it to do. So I just load that on there, and then it's a multi-step process that I have to go through every time. You have to, when it comes up, you have to say connect to the GPS receiver, and it goes out over the USB port on the phone, and then that hooks up to the GPS receiver. And the other thing is then you have to say connect to the correction server, and you click on that, and you can configure that. So you got to give it the URL, you got to give it your username, your password, the mount point. And once you get all that done, you say connect, and then that connects and runs. So I just need to get the steps down, because if I turn the thing off, then the thing disconnects and things like that. So I just have to play with that. Once I got it running, it seemed to work the entire time while I was out driving around. So I'm fairly happy with that. So I drove around the yard and picked 2 points, and I just drove to the first point and looked around and says, yeah, I can probably turn in this radius, and just stopped there for a few seconds, and then drove ahead another point and sat there for a few seconds, and then went back in the house, and I could look at my bag file and say, okay, I was at this XY location at this point and this one at this point. So I got the points I need now. I just need to feed those in the path generator and generate a path. And then I need to copy that over to my robot computer. And then I get to figure out which Python program that publishes that path for me. That's not on there. So I just got to copy those over and see if that runs. And if not, figure out why. I've got my robot computer still running 1604 and Kinetic. So it's running Python 2.7. And then, of course, my newer one's running, I think it's 2004 and Noetic, and it's got Python 3 on it. So yeah, I may have a problem. Maybe I'll just go to the top of the file and either change the name to either Python or Python 3, depending on what I'm doing. And it may be a little more in depth than that. So anyway, I'm at the point where if I had the ambition and the time at the same time, I could go out and try that. So take it out and turn it loose and see what it runs into. So that's what I've done on the robot. I gave some thought to simulators, and I was thinking that, the stuff Al's playing with right now, one thing you could do on the simulator is go into the configuration file for pure pursuit. It says, what do you want your forward velocity to be? Set that way down to like say 0.1 meters per second or something, and let it drive around the path. And now when you go look at the plots, the plots will change slow enough. You can, I think you can see the relationship between what's going on. So just that's a very simple thing. That might be a handy thing to try there. And then I was saying you could go out in your yard and manually drive around the path, have pure pursuit running, but don't let it control anything. And then check the values as you drive back and forth across the line and so forth. And I was thinking on the simulator, what we could do is we can disable it so it's not controlling by pure pursuit. And the simplest way to do that, there's a conversion node in there that converts from Ackerman stamped command. It converts that into an Ackerman command. So it's just a converter between the two. If you just don't start that, then it's not got, then pure pursuit will be publishing, but it won't be doing anything. And then just load up a joystick driver, and now you can actually just drive the simulator around manually and do the same thing you could do with the vehicle. So that got me thinking about what are some other things we could do to the simulator, come up with different ways to make that work, to make it more useful, like say for debugging and testing other things, because I basically just slapped it all together and got it so it was running and didn't really give a lot of thought to how to improve on it or make it more modular. So that's something that I was going to think about. And in order to do that, I need to make up a big diagram of how all this stuff works. So basically, so I remember how it works, and I can show it to somebody else and say, this is what it's doing. And hopefully they can understand that. So the other thing on the simulator is I had written a node that just goes out to the gazebo and says, read up the, I think it's called ground truth, which is basically your base link. It reads that value up and then externally just converts that into the odometry, the odom to base footprint topic that it publishes, and it also creates a odom to base footprint transform that it publishes. And it's simple enough, we can just turn that off and it will no longer just bypass the GPS stuff and then just load up since the GPS is already publishing, we could just go back and take one of the original, I think they were called GPS to odom.py. It's something that Matt either wrote that or copied it from somewhere. And I've modified that a lot over time. So I just want to take a simple version of that and say subscribe to the GPS and let it create the odom and the transform. And now it'll actually be using the GPS on the gazebo. And so you can go into your URDF file and move the antenna, move it sideways or move it forward or whatever you want to do, and then see what because that might immediately break it. If that breaks it and we can see it on the simulator that's acting like Al's physical vehicle, that says it's somewhere in the whole GPS and remapping process. And if not, then it points to something else. So I was just thinking about different ways to do that. So one of the things is, as I say, I want to diagram it. So I was thinking, I was talking about this a long time ago. If I take something like a Post-it note and just write on here, write gazebo and some stuff here, and stick it down to a piece of paper, and then over here say, this is URDF file, and then list some stuff here, and paste that down, and then come over here and say, this is the Ackerman controller.py, and there's list stuff. And then once it gets pasted down, you can draw lines between and say, this is what's being connected. So if I can do that, that would be a quick way for me to remember how all this stuff works. And then I want to find out some way to do that, say on a computer, so I'm not doing it on paper and redrawing the lines all the time. And that Miro board, that Miro whiteboard that Al is using and Bob Hassett started off with, that it may do that kind of stuff if I look at it hard enough. And I've got an old copy of Visio that might work. And so it'd be just nice to have a diagramming tool that lets me put down, say, a block like this and give it a title, and it gives us stuff here, and then be able to have, connect an arrow here to another box. So as I move this around, the arrows stay connected and all that kind of stuff. So that's kind of what I was looking at to do that kind of stuff. So that's kind of where I'm at right now. I've got lots of things I could do, and I just have to decide, am I going to do that or not?
Yes, yes. You said that you had an if and statement, so you had to have the motivation or something and something else or the time, and I hope we can make that happen.
Yeah, and speaking of all that, a couple of days ago, I went out to mow my yard, and I wasn't going to mow the whole thing, but I was also going to mow all of what some people call the boulevard, and around Minneapolis they call that the public access area. It's the area between your sidewalk and the street. And nobody, since it's been dry, nobody's been mowing, and the yard just really looks, the whole neighborhood looks like hell. So I went around all the way around and mowed that stuff. And it wasn't really that hot, and I wasn't really working that hard, but I got a case of heat stroke before I was done, and I didn't realize that I was all done. I sat down like, oh, I hope I don't die. So that just more things on my list that get just occasionally get thrown in, like having to go out and mow the yard or clean up trash or whatever. So
Yeah, please don't get heat stroke.
that's I guess that's basically where I'm at and what I've done.
A few things to share from my end. Let's see if I can get back to the share button. So I put a post out on Slack to try to summarize where I was. So a little bit of this is going to be repeat of that. But if I go to my Miro board, I've got the number of screen prints out here, and effectively I'm trying to run this path, and I've run that in simulation. And as Jeff alluded to, the simulation, one of the key components of the simulation is it produces an ODOM statement, and it's getting that from Gazebo. I don't know if you can see the title of that file, but this is the file that runs in simulation and produces an ODOM statement. And one of the things that caught my eye is a data element called result. So it's getting linear X, and it was really the transform that, so here's the transform that produces, because I'm sort of thinking I have a problem with replicating this transform. I'm in the real world, I'm using this Python program called ODOM, blah, 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 from wheel and GPS. And I produce a transform as well as an ODOM statement. In this code, and it's made up of two, primary components, the X and Y position, and then the data that I get from an IMU. And the reason I'm focused on that is because this program is the actual pure pursuit program written in C, and it, in a couple of different places, uses this KDL, kinetic dynamic library, and creates, this says a vector, that's not the one that I'm looking for. I'm looking for one that creates a frame. No, here it is. No, that's not the one. I need to be in compute velocities. Oh, that's the informational thing that I'm printing. Bear with me as I scroll up. So here's one of the examples where it's producing this frame, and it's taking as input a pose, which represents the goal, and a transform, which, as best I can tell, represents the the as is position of the robot, and then it produces this frame. Now, what's the obvious thing that's sort of a smoking gun here is that in simulation this all works great, but in the real world it doesn't work great. And when I say it doesn't work great, if I go back to trying to run this path in the real world, I've got a series of data here, and this is real world data, and this red line is the actual path that it's running. The blue line is the target, and it almost comes up to the line, but it doesn't quite get there, and then it starts to veer off to the right. And it's in simple terms, it's veering off to the right because it's getting an Ackerman steer angle of 1.6, which is an incredibly hard turn to the left. And when you track this X and Y position from the transform, which I thought would be, I'm sorry, this is the frame, because I was trying to figure out what that KDL library is actually doing. When I give it the data that I'm giving it, X seems to be going down appropriately and getting closer to the lookahead point, which if this blue line were extended, it would be up here somewhere. But the Y data, you can see up here, it's starting positive, which you'd say, yep, that's right, you're on the left-hand side, that should be positive. But I'm still on the left-hand side, and then it goes negative for some reason. So the end result of all of that is, in simulation, you wouldn't see this behavior. You would see more typical behavior, that it would go to the line and that number would continue to get, the steer angle would continue to get smaller, and not say, hey, go veer off to the left. So, my path of exploration at the moment, this is actual data from the simulation. And the reason there's multiple red lines there is because it actually ran this path multiple times, but this is the very first time where it's coming, the tractor's coming in from the left, and then it's got to turn and go up the y-axis. And as it progressively gets closer to the path, as you would expect, the x-axis, comes down until it gets to the next waypoint, and then it goes up and comes down. And the y data, comes down to close to zero and stays close to zero until it gets the next waypoint, and then it's a little bit off and it's got to adjust and comes down. So my current train of thought suggests that I'm not producing the transformation correctly, and I don't know what I'm doing wrong. And in an attempt to try to understand what am I doing wrong, I guess my next step would be to go back to this ODOM from gazebo. It's producing data from result, and result comes from this service call right here. So I think for me, it's looking at that get model service and say, are you doing something? How are you pulling that data? Because I need to replicate that if I want the same behavior. So that's where I'm at. A couple of things that I'll also show is, in the meantime, I wrote this script that I hard code in a current position and a path to follow, and I say calculate the angle to the goal. And the reason I did that is because I wanted to make sure I understood it correctly, because I will admit that kinetic dynamic library and using frames and transforms to affect, the goal is to get this angle to the goal, and I was not understanding exactly how that was all going down. So anyway, this is a little program that I wrote to calculate that and do it in multiple examples, and make sure my understanding of how to calculate angle to the goal following the pure pursuit method is going to produce something that is accurate. So that's
So what is that program based on? Is that um, based on the code that we're running with both the simulator and your physical vehicle, or is it based on somebody's like that original Pure Pursuit paper, or where did you get the steps to do that?
um, so this program called path underscore pp underscore v2, that's I went to that paper. I started with that paper, and then effectively tried to implement that paper. And so there's a series of steps to do that. That I mean, the paper for me wasn't. It's based on that paper. My interpretation of that paper is the answer to your question.
I was just looking at your diagram there, and it said you have closest point labeled, and that's the closest horizontal point on the path from your vehicle. And I notice if I go look at the code we're actually running, I didn't think they were calculating that, or maybe they were, maybe they're just calling it something different. So I'm just curious what's that based on, and does it, should it match what you're doing right now? And since the stuff, the code we're running says they based it on that paper and tried to use the same terminology out of that, it seems like it should, it should be the same stuff. It's just that I didn't remember that closest point. When I went and searched for that in the stuff, I didn't see anything called closest point showing up. But apparently, you need to find that point in order to find the distance to your look ahead. So I guess that, you got to come up with somewhere. I just wondered where, what you'd base that on and so forth.
Yeah, and I it was not clear to me how in this Pure Pursuit, C program that we're using, that they replicated that paper, although I'm sure they would say they did. Um, that's why I went off and said, how is this supposed to work? Because I don't quite see how they did that in using these frames and the transform and now it can, it's all buried in I mean, the end result is, this is 2 times, let's see if I go back to this. We'll work backwards. Yeah, I mean, there's the quintessential steering angle calculation, 2 times the wheelbase times the sine of the angle to the goal over the look ahead distance.
You're not sharing if you think you are.
Oops, I'm sorry. I meant to be. So this is my, trying to use long link verbose variable names, and this is the Python script that I wrote to try to visualize what was going on. And I called it the quintessential Pure Pursuit formula. Is you get the steering angle by taking 2 times the wheelbase and the angle to the goal divided by the look ahead distance. In the Pure Pursuit, that's that's here. And look ahead distance, that's a constant. Wheelbase, they square, but I'm sure an algebra teacher could tell me why they square that. And so I was focusing on this the YT calculation, and that comes from whatever's happening in this transform. So again, there's something special going on with this Y value that I'm not, that is definitely not the distance to is definitely not the Y value that I'm populating in my, ODOM from GPS. I'm just simply taking the actual position. So for me, I think the next step is to understand this is the ODOM from Gazebo. What are they doing to calculate that Y value? That if we click back over to the
Back up to it. Yeah. Is that, yeah, right there. It says lateral error is the Y value of the look ahead point in base link frame. So I think what that's saying is, it's the difference between, I think, where you are, the Y value where you are, and the Y value where it says the look ahead point is. So if you're just taking, say, the Y value, say like 21.2 or whatever the number is, I think you actually want the 21.2 minus where your base link is, I think is probably what that's saying. But
Can you
I'm,
talk about that a little bit more, because I don't, tell me give me more words on what you think the calculation of that is.
well, I think they're trying to decide how far off are you from where you should be. And it sounded like you were saying you was taking the Y value of, if you're taking the Y value of the look ahead transform, which gets, when you run it, that gets plotted onto your whether you run it in RViz, or I guess even when you run it in Plot Juggler, you can see that look ahead point advance up your path as you move along, and that's at something like 21.4 and 10.5 or whatever that is, based on your origin or where you started. And yeah, hold on right there for a second. Because another thing I was going to ask you about is that line that says target steering path. Are you expecting the vehicle to follow along that yellow dotted line, or do you
No,
expect
I
it
mean,
to, or do you
because it's
expect
an
it to follow?
Ackerman vehicle, it's going to sort of turn in that direction, but it's not going to be
Because I think
instantaneous.
what they're trying to do, inevitably, since they drew that circle on there, I think they're expecting you to set a steering angle that will make the vehicle travel around that arc, stay on that arc until it gets to the next time you do a calculation. So that's why I was wondering what that yellow line, if you're actually expecting to drive on that line, or you expecting to drive on the blue circle.
I
And then,
plotted that line to say, does this steering angle or angle to goal seem reasonable? And if it wasn't pointing in the direction of that, of the goal, then I knew something was wrong. So it was a reasonableness test.
so is that just a line plotted between your orange dot and that purple dot on the left, or is it actually from the orange, it's just an angle? So is it a vector, or is it just drawn between those 2 points there on the screen?
It is a plot of this angle from the current position.
So it so it so it's kind of maybe coincidental that it's going through that dot on the left, or that just simply the way everything works out, that's just where it comes out. So anyway,
Well,
I just wonder which one of the things you're trying to control on there.
it's purely there for aesthetic reasons, because I this is the plotting part of the so that there's no how do I describe it? I wanted to see where, if you had a vehicle that could instantaneously turn, which direction would it be turning in, is one way to say it.
So it's just a debug thing that you put in to,
It's purely a debug thing. The
okay.
actual angle you know, is 0.11 radians, and it says turn 0.11 radians, as we all know, if it's an Ackerman vehicle, so it's going to turn in an arc. Yes, this circle is meant to represent that arc that's used to calculate, you know, how do I intersect with that purple line in an Ackerman vehicle.
Okay.
But anyway, if you wouldn't mind, can we go back to your, let's see, back to pure pursuit. If I, so keep this sentence in mind. And this, I mean, forget how I came up with this chart. With these three data points, you've got, you know, the current position, the closest point, and your goal. What do you think that YT, here, I'll move this out of the way so you can see it. What do you think should be populated in this transform.translation.y?
So I think either along your path or along the heading of your vehicle, it wants to know when it gets out to that goal point, how far is it? How far is that line from your goal point? So either how far is your vehicle off the path from the look ahead point out there, or
because we can see
if
the
you project out your heading, if you had a line for that, you might want to know how far is the heading off from that point out there. So that off track error, see, at one point I thought off track error was simply, yeah, right there where you're pointing. I thought it was the closest point to the vehicle, but I think somewhere it said the off track error is actually how far the vehicle is from your goal out there. And I don't remember where I saw that, but you know, if you go look at the code, I think in pure pursuit, when it says calculate off track error, I think it said that is it's the Y difference between, somewhere it said the Y difference between your the look ahead point and something else, and not between your vehicle and your closest point. And maybe that's which way do you how do you think they're defining off track error there?
Well, let me answer that in two ways. Number one, this off track error is a simple calculation of distance between the green dot and the red dot. I also saw some charts that had that distance. There were two variables in that distance. One was a Y and one was an X. And I didn't understand that. So I remember a chart that seemed to suggest that there was, you know, I mean, and again, this isn't used in any calculation. It's here for just informational purposes. It seemed to be some, well, I saw one chart, at least that I can recall, where they used two variables to describe the distance between that green dot and the red dot.
So I think in the official code, where they call what they call off track error is not the difference between those 2 points. It's the difference between your vehicle and the look ahead point, your goal point out there. So you got to be careful about using the same name. You make it up your own name that matches the name they're already using for something different. So that kind of like, it goes back to where you kept saying you had horse over ground from GPS, but in reality, horse over ground from GPS is if you go to your RMA NEMA sentence, there's a field in there called course over ground. So that's the official definition of course over ground from GPS. But you wrote your own code. You were taking the latitude and longitude and doing a bunch of calculations on that, and you were calling that course over ground. Which, see, now those two names don't match. And that's why I got so confused that meeting when we were talking about you kept saying, no, this is course over ground from GPS, which no, it's a calculation you made from the latitude and longitude from GPS. Whereas if you go back to the official definition, course over ground from GPS is a field in a Neiman sentence that tells you what your heading is. So anyway, that's getting off track here. Just you got to be careful about picking a name that matches a name that's already in there, but they mean two different things. So I just wanted to just bring that up.
But again, looking at that comment and that line, you've suggested in
So I think what they're saying
my
there,
head is
you're
two
going to get.
different possibilities on what that YT is.
So I think you've got a transform for your vehicle, which is going to be whatever. It's probably going to be the incoming ODOM transform, and it's going to say you are at this XY, and you got this heading, and then it generates a transform for that look ahead point that's out on the path. And I think if you just take the difference of Y values between those two, might be what you're looking for there, because that's where it says it's the Y value of the look ahead point in base link frame. So I think it's just telling you the difference between your vehicle Y and the look ahead point Y is what that's telling you. That's my guess. I haven't actually tried to prove that, so I don't know.
So let me test my understanding. It would be, I mean, the X value of this look ahead point is, let's just say is 2 meters. Well, it is because those boxes are in meters. That purple dot is 2 meters in front of that green dot. And we all know that that's going to be close, but not exact to the red dot. And so I don't know how to ask this question. If I go back to in the real world, calculating an ODOM statement and a transform from GPS data, at the moment, this is simply what is the actual position of the robot. You are saying that it's the distance. What are you saying? How do I calculate that? I'm talking to myself. Yeah, I'm still not sure what I would put in there. Well, it wouldn't be the actual position. It would be the delta to something. So it's the delta to the goal, right?
Well, another thing to keep in mind as you're looking at this stuff, even though it says X and Y means something different depending whether you're talking about in the world coordinate system or on your vehicle. So somewhere, if you're on your vehicle, then X points forward in your direction of the heading. And if you're in the world coordinates, X is, at least when you plot it, X is pointed up. So the X, your XY plot in the world is what you're getting on your ground truths when you plot out a ground plot driving around. X, let's see. No, X is actually, like, in normal term, X is back and forth and Y is up and down in the world coordinates. But once you move on to your vehicle, X is the direction pointing to the front of the robot, and Y is the direction coming out of the side of that. So don't just say, well, I need X and Y. You gotta know what, which frame you're in when you're talking about that. So in this case, it says broadcast transform between ODOM and base footprint frames. Transform. So ODOM to base footprint is going to be, I believe that's going to be in the world coordinate system. So this X and Y is going to be, if you're looking at it, from a ground truth plot, that's what that X and Y means. And then once you get onto the vehicle, your vehicle can be pointed any direction you want, and the front of the vehicle is always pointing in the X direction, and out the side is always pointing in the Y direction. So that's just something to keep in mind there. Don't just mix these back and forth because they say X and Y. You got to make sure you got the right one. And just another minor point, that if you put that code back up you just had. And you notice down there where you're loading that quaternion down there, keep in mind some of the functions will list the quaternion in the order of XYZW, and some will list WXYZ, so that something is swapped around. And since you're writing it to a structure where it says .x, .y, .z, it knows where those are. But see on the right, you're saying pull it out of quat 0, 1, and 1, 2, and 3. So those may be in a different order than what you've got on your what you're loading those into. So that's just something else to keep in mind, that sometimes they list the quaternion in one order, sometimes they list it in a different order. So whatever your where it says quat 0, 1, 2, and 3, depending how you stuff those values in there, you got to make sure they're in the same order of, make sure 0, 1, 2, and 3 are X, Y, Z, and W in that particular order. Otherwise, it can be swapping values around.
If I go back to this data, so what you're looking at is simulation data, and data element 22 is X, and
So which X is that?
yeah, bear with me a second. I will answer that question with incredible specificity, but I need a cheat sheet to look it up. And I know that it's so it's coming from the, did I say 22 and 23? I did. So it's coming from the lookahead transform translation. So if I go back to this, and so it is, yeah, see, that's bizarre because it's not, oh, come on. For some reason I'm used to, bear with me, I know how to get out of this. Control Z makes it go away. So that red dot is, the actual position, blue dot or the blue line is the path. So we can look at that and say it's just below, it's like a half a meter away. And it's a long way away from this next look ahead position. Well, this X, I can understand. I mean, it is that distance. But look at the value.
Which distance? You say it's that distance, you're going all over the place. Are you talking about the distance from the red point to the path on the right, the closest point, or you think X is from the red point up to the blue dot?
I believe data element 22, which is the transform translation X, is the distance between that blue dot and the red dot. That's my working theory. What I have no idea about is if I look at this physical representation, what in the world is that Y value? Because it's not half a meter, which is the distance between the path. I don't know what that is. I mean, because it's like 0.1. If I just move the screen down a little bit so you can see where it intersects. I mean, it's intersecting at basically 0.1. And I look at that and I'm like, well, 0.1, it's 0.1. Where is it pointing to? So that reminds me of when I was looking at it before, I'm like, I don't know what the hell that Y value is. In simulation, not in my real world, but in simulation.
And the other
Yeah.
thing that it may be, if you were to draw a vector from your red dot that represents your yaw, represents your heading, and if it might be that it's pointing at your goal up there, and it says when at this angle when I'm pointing at it, it's that far off. So maybe that's where your point one's coming from. So see, you got your red dot there. If you knew what your vector was coming off that for your heading, which if you run this in RViz, it might be easier to see that. It's pointing up there towards that blue dot. And whether
No
it's on the
doubt.
right side or left side of that, it might be off by, the crossing point might be off by 0.1, maybe is what that's telling you. And I'm just guessing at this, but that's another explanation of what might be happening here.
And so I thought going back to the gazebo, since this result is populating that transform, trying to figure out from that this code, what is it populating that
Well,
Y value with?
I believe what that's giving you is your actual XY location, XY and heading location in the world coordinates. So, it's going to come up and say, if you go back to that plot you just had, it's basically going to say your thing is going to be an X of 20.9 by whatever the vertical distance is there. That's going to say that's what your XY is. And then your heading is going to be whatever direction is pointed. So that's telling you where in the world, where on the map you are, the values coming out of there. So it's just the same as if you had, wheel odometry tracking where you are in the world, or you have the GPS tracking where you are in the world. They're all saying you are located here in your yard, from our offset point of where we started. That's what that particular thing is telling you right there, I believe.
That's entirely reasonable. And what's confusing is, I mean, this is the pure pursuit program, and all I've done is added some debug statements down here. And that 22, 23 data elements is that transform. Oh, I'm sorry. This is the frame that KDL thing creates. So this is the actual transform. And so I print off, I store in a topic the actual position, the post statement, this transform, and then this is the result from the frame. So what maybe then looking at the gazebo won't help me, because if it's just publishing the actual position, it's understanding what the hell that KDL thing is doing.
That
Well,
that's
no,
that was the intention of what that program is doing. It's publishing your actual position of where you are in the world. So I don't think it's going to do any good to go through that to see how it does that, because I just simply go out to gazebo and say, tell me where you are, and I take those values and stuff them into take the XY value in the world and take the heading in the world, and I just stuff them into the ODOM topic and the ODOM transform.
yeah, see, then why am I getting different behavior from simulation versus real world? And that's not a question necessarily of you, it's just that means then that would suggest then that, hey, this is no big shakes. You just drop in the actual position, and that KDL thing would work fine, whether you're in simulation or real world.
Okay, right there at that point, you got those highlighted, and it says you want to load the translation X with something called self.x. Well, what created that self.x?
It's going to be that's the magic of, the GPS position when you get RTK fix. And although there's X, well, it
But
comes from RTK, and
that's
it
my
comes from
my point was, if somewhere else in the program where it's, you again, you're just calling it X and you're not really giving it a reference of what you're talking to, as long as it's local enough that you can say, I just created something called X that came right from my GPS, and you're going to use it immediately, then yeah, I guess that should work.
I mean, it is. Um, the simple answer is that X is the X and Y position. When it has RTK, it's coming from, this latitude and longitude data fed into this function called LL2XY. And then I temporarily store it in GPS, and then if I've got RTK fixed, then I use the GPS data to populate that X and Y position. Otherwise, I use the wheel position to populate that X and Y.
Okay. My point was X and Y are quite generic, and depending whether you're talking about something in the robot frame, you might call it X. If you just generically call it X in your program, you may not know by the time you get there which one, what's the last thing that populated the variable X. But if that's the only thing you use an X and Y for, then it shouldn't matter.
Yeah, if I go back to my unknowns, an unknown for me is, what is this Y value? That's an unknown for me.
So keep that in mind. Keep that curve in mind, and say, as you're approaching your point, you can see it's coming down closer and closer to zero as you're, say, essentially going around a curve to get to your point. And then that other code you just had where it said that the what do they call it, they said that something is the Y value of your look ahead transform. Well, it's basically, so I think it's the fact that it's probably calculating the vector of your heading from your robot. See, if you look in the upper left hand corner, you got your red dot. So I think if you could extend out the heading line as a vector, and it's pointing at that blue dot up there, it's telling you how close, either that, or as you get closer, see the red dot goes up, you're getting closer and closer to the path. So it's that yellow plot down the bottom, see, it's getting closer and closer to an offset of zero. So I think and they're probably talking about Y in the with regard to the robot. So Y is, say, how far out the right hand side of the robot am I from whatever we're looking at, whether it's directly to the path, which you're calling closest point, or at the top it's saying how far to the right of the center line of the robot are we from the goal point. So if you extend the center line of the robot out, which is what your heading is, and then it's saying how close is that heading line from your goal line here. So as you come up like this, you're getting closer and closer, which is shown on that graph there in the upper left. So you can see that's getting closer to it. And then while it's doing that, you can see the yellow line at the bottom. It's saying, okay, our distance to whatever is getting smaller and smaller until it comes down to a difference of zero. At which point, then I think probably if you go look at if that, I don't know, if you go look at that path in the upper left, how far up does that go? Does it just stop at the goal point, or is it, because I assume at that point, see, you're basically you're on the path and it's going to follow that. And that's why it's saying your error at that point is dropping to zero, because then it does a pretty good job the simulator does a pretty good job of trying to start up that line.
Yeah, um, and so I'm keeping in my mind what's the difference between simulation and real world and what can I influence. And your comment about um, I can't change the KDL way that it calculates a frame, but this orientation, if I don't have that right, I mean that could bleed through when this transform to base link thing fires up and takes the transform that I've fed it. I'm just talking out loud because I'm
What
trying to.
what point does it actually load that array where it says quat 0, 1, 2, and 3? Where's it actually loading values into that?
So I'm back to my GPS ODOM deal and quat. Probably just easier just to search for quat. Come on, find the right program. Oh, that's from ODOM GPS or quat. Sorry. I mean, that's the first one, but that's just an initialization. And it takes the heading from the IMU. And then in the IMU callback, nope, that's not it. It comes from that function quaternion from Euler.
So you may want to look up that function because I assume when you're done, you just simply let Python say copy this array to this array, and it puts them in whatever order they are. It doesn't know what the order should be. And so look up quaternion from Euler and see what the definition is on that, where it says, I'm going to load up this array with these 4 values and see what order it's putting in there, and make sure that's the same order that everything else is using.
That's a good suggestion.
If you swap those, that really screws things up. So in fact, not only does it swap them, I think it pushes it down one. So then I think all 4 values are wrong if that happens.
What is it? Python? That might be a ROS deal.
Yeah, it's probably in the transform library for ROS, but if you maybe on your search, what do you got in, right? You put ROS on the front of that and see what it.
I want to go from. Well, let's just see if there's anything useful there. Oh, that's really
Is that the direction you're going, or are you going from Euler to quaternion? The stuff where you were just looking at. So
Uh,
it says quaternion from Euler, so you actually want Euler to quaternion conversion, which is, I think, see, you either get a from or a to between those, and I think the stuff you're just looking at said Euler to quaternion. No, it says quaternion to Euler. So you actually want to say quaternion from Euler, not quaternion to Euler. When you do the search, I don't know what your search term said. It's quaternion from.
Copied the function.
It's just the search engine doesn't seem to understand what you're talking about.
So
I would just say ROS Python quaternion. Maybe you want to say Euler to quaternion. And maybe take to format off there, just so you get a general idea what you're trying to do here. Okay, so down there he says, see, he's got that example. It says convert that. He calls it, and it does say 0, 1, 2, and 3, and it does say XYZW. So that if that's correct, then what you have should be correct. It just, there's at least one or two functions that don't return that in the same order. So that as I say, that's something to keep track of. It might be the C++ version is the one that acts differently. So, but here you got it exactly like they just showed there.
maybe it's all the way back in my IMU. I mean, that's the
And the stuff that's in question here, is it the odometry stuff you're publishing, or what was the original question here about a transform being right or wrong? What were we trying to look at here?
well, this y, as it's calculated using my actual data, is not allowing the robot ever to get to the path. So, I mean, that is, it lets it get close to the path, but then it sends it off. And I didn't mean to do that. You know, in the simulated data, that was a nice gradual slope. This is sending it off into, it's making it go a left-hand turn. And it's getting this, you know, really high, half a pi steering angle. So my path to understanding, probably shouldn't use path, was trying to understand, well, what is this y that it's calculating, and how is the transform that I'm feeding it influencing that. So that's sort of the, I don't know, the issue that I'm struggling with, because this is a beautiful path that gets it down to 0 and keeps it there.
Another thing I looked at one time, I was just plotting random stuff out of your data, and I think if you plot go into Plot Juggler and say plot the look ahead transform, or I can't remember what it was called. It was like under look ahead data. If you go into the one that says plot the transform, and then under transforms it'll say, I think it says base link to look ahead. If you go plot that, it looks really stupid compared to, it doesn't show you your XY location in the world of where your look ahead marker is. It's showing you it, it's kind of bouncing all over the place. And um at first I thought, well, that can't be right, but the more I looked at it, it kind of bounces back and forth by about a meter or so, and I think that's as it's switching look ahead points, that's why it's doing that. But then it's in some kind of a semicircle pattern that it plots that stuff in. So that might be, what you're looking at right now, telling you the differences of your two transforms, as opposed to saying this is where the look ahead point is in the world. It's telling you the difference between your base link and your look ahead. So if you pull a plot juggler and look at that, then maybe that'll give you a clue.
Yeah, I'm not sure how to process that. I am. So this is the transform that's used as an input to that KDL frame function. And I'm, capturing these are the two pieces of data that go into that KDL frame thing, the pose and the current transform, and it spits out this.
So I believe that's going to spit out the difference between those two. It's not going to give you an XY position in the world. It's going to say from base link to your look ahead point, or your pose point. It's going to say it's a difference. It's this far ahead and this far to the right, and then at whatever angle those points are apart. And that's why I'm saying, if you go back to Plot Juggler and plot that, then that'll show. Then that shows up. And I don't know if I did that between the simulated data and your data, but that's just one of the things I ran across. And first I thought that looks wrong, but the more I thought about that, maybe that's right. It's actually showing, by doing that transform between those two, it's telling you how far apart they are, and what angle they are from each other, as opposed to, if you watch it while it's running, that plot you just had in the upper left hand corner says here's base link and here's my goal point. Those are absolute positions in your world. That was a different plot you had.
Yeah, I mean, this is the actual data, or this is the field test, and then this is the data from the simulation. Why is it changing size? Stop. Where did you go? So I'm pretty confident that X, yeah, it's this Y that I don't understand, but I don't need to understand it. But I need to understand it well enough to say, why am I screwing it up? Because right now I'm feeding it data that doesn't give me this nice gradual thing. It gives me that jagged thing as it's coming up to the line. No, I'm just repeating myself.
Can you pull up Plot Juggler at this point?
Sure. Kill this. What, simulation data or real data?
Either one.
go with simulation data.
Then when it comes up, go to your menu on the left and go all the way down where it says transforms and open that. It says TF, open that.
Roger that.
And yeah, open that. And it'll say, I think it's open base link and see what's under that. Yeah, open that one. And open the position on that. Translation. And then plot your XY as a scatter plot. So right click and drag. And see that looks odd when you look at it. Now, if you go look at, and I think what that is, that's the difference between base link and your look ahead point. So if you zoom in on that stuff down at the bottom where it's got that all that squiggly stuff, yeah.
Now remember, this is
How-
simulation, so this is,
How are you able to drag that like that? When I drag it, it tries to resize it if I do that.
I was just using the scroll wheel and pressing down.
Oh, okay. I need to look into that. So anyway, you can see that it's kind of a slight the big blob of stuff at the bottom. So it's kind of you can see there's a slight curve to it. See if you look on the that right there, there's a slight curve, and I don't know where that's coming from, but as those points are bouncing back and forth, I think that's as you go from one look ahead point to the next, it's saying, okay, now we're closer, now we're further away, now we're closer, now we're further away. Now, if you go look at that on
Well, I
your,
mean, we can dig into that if you want. Let's see. Look ahead. It's gonna.
so I think the big arc around the whole outside is the difference between where you started at 0, 0 as you're driving towards the first path. That's probably where the that big arc is as it goes around there. And then once it gets on the path, then I think it jumps to the bottom there and starts doing that as you're driving around.
It's driving the circle.
Is there a way to copy one plot to say if you were to split the screen and then can you copy it, or do you have to replot it when you do that? Because you could put these side by side or up and down, and then as you drive
Now
around, you can see where you're at. Yeah, so on that one, just plot whatever that stuff on the left that you just had. Let's see, what was that? Yeah, that one. Plot that one at the same point. As you drag it around, I think as soon as you get to the start of the path, when you start off at let's see, it's probably gonna. Well, that's not where I expected that to start. Oh, yeah, you're not at the beginning. If you go all the way back to 0, it's either going to be the center of that big arc, or it's probably going to be at the center of the big arc. As you start going right, on the green dot, you'll see what will be approaching the path, and I assume that'll come around. That's as you turn in. As soon as you get the path, and it's going to jump to that mess over there. So I suppose the little arcs that it's drawing there is as you're turning loops. I don't know why that's bouncing back and forth, but I think that if you were to zoom in on that while it's running there, I think that's basically that's again that's the XY, that's the um that's the difference between base link and your look ahead point is what that's showing you right there. So it's not showing your XY in the world, it's just saying here's how far away these 2 points are.
Mhm.
And if you go look at that on your real data, your outside data, it looks somewhat different, but it looks kind of the same. And I don't know if that's really telling you much or not. So
See, that's coming down. What I don't understand is the why. Not sure I need to. Well, I need to understand why the heck simulation works and real world doesn't.
well, that orange thing right there, what that was telling you, if you look at the peak at the beginning, it says we're 20 meters away. This is the vehicle pointed at your destination. So it says from the front of the vehicle to the first point of the path, we're 20 meters away. As we start
I get
driving
that.
closer to it, that just comes down to the point where it's going to get. So that's your forward direction to to your goal is what the
But
orange
it's the
one's telling.
why that's in my, the unknown for me is the why.
And then on the Y, again, so and keep in mind this rotates as you go. So when you start off when you're at 0, 0, when you start off, your vehicle's pointed down. And since it's pointed down, it says um, off to your left-hand side. Yeah, off to the left-hand side is 20 meters to that dot over there. So then as you start to rotate around, you start to go around that curve, that's when the plot starts coming down and it gets to the point where keep going a little further. So stop right about there. So now it says, how far is it from, in this case, from the left side of the vehicle, how far it is to to our start point. And it says, well, actually, I guess to the goal point. So it's pointed right at the goal right now. So it says our error from the goal from where we are is 0. And that's because it's plotting out the center line of the robot and saying, where does that cross our goal point over there? And it's saying, well, it's close enough. It's right on. It says our center line of our vehicle is pointed right at the path point out there. So as you drive along, it stays at 0 because everybody's happy. So see your distance on the left says we're getting closer to the point, and the one on the right says we're still pointed right at it, is what that's telling you right there. So now when you get right there, then other things are going to more fun stuff's going to start happening as it tries to turn and line up. So I think that's what it's telling you. It's the center line of the robot pointed at your goal. How far that's what they're calling off path error. So when that center line crosses the path, it says how far off from that are we, either left or right. I think is what that's trying to tell you. And that's why we looked at another one that was called the base link to look ahead transform. That's telling you those things. It's saying, here's how far we are from where we are out to there, and each one of those has like a heading or something. So I think that's how it's determining, because you take the heading of base link, that's the center line of your robot, and then off to the left or right, because your thing you're pointed at, the pose out there, that's going to be to the left or the right of that center line, and that's what your little thing on your pink line at the bottom. I think that's what that's telling you. So how that answers your, solves your problem one way or not, I don't know. But I guess one thing you can look at, so we know what this looks like right here. And if it's convenient, just hit your screen print so you can come back to this if you really need to. And then go plot this same thing on your actual vehicle data and see, because when this starts off, your vehicle starts driving down, has a nice curve, and then does a straight line over to your path. And if your real data can't do that, then you got, I think, a real serious problem. So I guess where it starts off and starts driving down at the beginning, it is a fairly smooth curve there. And where'd your data go?
Yeah, I guess it decided to reload. Um, Did I have base footprint or base link in the last one?
Well, technically it doesn't matter because they're both mapped on top of each other. It would be best to make it consistent all the way through, but since they're both on top of each other, that I don't think that should be a problem. They're on top of each other. They just have a different vertical height on the two.
This is the screen print. And it's got base link. Shouldn't be a problem. Because I have base footprint. Anyway, that's why that disappeared.
Oh, yeah, okay. It's also odd on the lower left graph there. Didn't the other one start at 20 meters off? And this one's only starting at like 4 meters off. And again, I think we decided that's the distance between where you are and the goal you're looking for. If you still got that screen print handy.
Mm-hmm.
Oh, I guess it doesn't start at 20 meters off. It starts at, what is it? Around 5.5 meters. Well, mm, before those both said 20 meters, and now, we're looking at the wrong. I don't have my glasses on, so I gotta look harder here. So that's your transform base link to look ahead.
Trying to scroll in.
Translation X, translation Y. So I thought somebody we just looked at said it was both of them started off there like 20 meters away or something. So
That was the real, that's the field test data from, this is the field test data from, actual.
but I thought when we looked at the simulation, they both said they were 20 meters off, which probably would have made sense on the simulated data. But I don't know. So
Well, it does. I mean, there's definitely, 20 meters between 0, 0 and the first goal.
but your plots are only saying 5 meters. So why why is that? So that might be a clue right there. The fact that, well, but again, this is the simulated data, right?
Roger that.
So this should be correct. I don't know. Huh, huh, huh. I guess I'll have to think about that.
Yeah, but here, this translation Y is coming out with a crazy high number compared to I guess there it is 4. I don't even, in the world of
Um, here's something to
ratings, I
here's
don't even know
something
what
to note. If you look at the plots on the bottom, they don't start at 0. They start at 40 something. So we're missing the data off the front of those. If you drag your slider, oh, this is the
I have to
screen
go
print,
back
is it?
and read it. Yeah, this is a screen print. I'd have to go back and reload, which I can.
Oh,
Reload.
that's what happened. You were zoomed in, I think, when you did the screen print. So when you start off at 0, 0, it should say that the Y value is going to be off by 20 meters, and the start down, the X meters, the X distance can be off like 5 meters or something, I think.
Yep, 20.
That's where I saw the 20 meters. So technically your other one should be doing that too. So what that's telling you is, if you drag your slider at the bottom back down to 0, maybe just have to reload the top plot.
The time value is
That what do you call it? That thing at the top that's got the oh, there it went back to 0. It just had to jiggle a little bit. So see your vehicle's at location 00 in the world. You're in your garage and you're pointed down. Now, when you do that, it says, since you're pointed down, it says off to my left-hand side, the X distance is going to be 20 meters. And you go look at your thing, it says, yep, we're 20 meters off. And now
but look at
the
why.
the other one, see out here in the beginning, it's got some small value that I can't read because there's labels on top of it. But as you start to go around that curve, now those two are going to swap, and now the X distance of the transform, which is now out in front of the vehicle, says from after you get around that curve and you're pointed at the path, it says, okay, we're now 20 meters distance from the start point. And it says since we're pointed at the point, now the Y value down there, which is your sideways error, is going to drop to 0 as we drive along that plot there. And I don't think your other one was doing that. So maybe at this point, just screen dump with this one, and that way we've got the zoomed out one so you can see what you actually got.
Do a screen print of this.
Yeah. If this is dragging on too long, we could do this some other time or whatever.
No, no. Hey, I've got nothing better to do. So I've taken a screen print of that.
So then if you go back to your other, does that make sense what I'm saying here? So when you start off, your vehicle's pointed down. So at the top up there on the top graph, when you start at 00, your vehicle's pointed down, which means off to the left of the vehicle, the distance from there over to your path point is going to be 20 meters, because that's just what it is. And then looking straight down, let's see, so the Y value is off by 20 meters, and the X value as you're pointed down, X value of the vehicle is the difference between that point and the vertical on the start of the path. So that's what, 5. So on the right, at this point, are we still live here? Can you zoom in on that graph on the right on the bottom at the very beginning and see what angle it's starting at, or what distance it's starting at? Yeah, right in there. So that starts at 0. So let's see, if the vehicle's pointed down, I just assumed that would start at or did the left one?
Run this for a second to get the. Here, I'm going to slow this down.
Just this initial X and Y offset baffles me. I don't understand why it doesn't say. Right. And maybe it's because what does that one say?
I literally can't read it. I mean, it's negative on the X and it jumped up to 20 on the Y.
Negative what on the X? What do the numbers say on it? The label. What's the label?
3.5. The label. This is translation X. Look ahead, translation X.
Negative. That negative. So that I suppose that could be right, that it's that far, because if you look at the point on the top again, if your vehicle's pointed down, that means the start of the path is going to be behind the vehicle, that would be a negative value. And it does look like it is about, I don't know, somewhere between 3 to 5 meters. So that maybe that is correct. As soon as you start the thing, it says the distance between the back of the vehicle and the start point over there is about that much, behind the vehicle. Then as you start to turn, as you come around, then so the vehicle is now pointed at the goal.
So it's saying it's got to go up 4 meters, which would be this way, and
Well, at this point, it's not saying where do we got to go. It's just saying from where I'm at to the goal point. This is how far away I think we are based on the 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 vehicle. What do you call it? The vehicle frame. So on the vehicle, you got out the front and you got out the side, and then as you rotate, then the front of the vehicle rotates around until you're pointed at the path, the goal out there. So when you first start off, it started at 0, and then apparently, so for some reason, then it jumped to that minus 3.5 or whatever it was. So that's when the thing actually started and says, "Oh, in while I'm pointing down, that means the goal position is that 3.5 meters behind me." And if you would just sit there without driving anywhere, it would just stay like that. And then as soon as you start driving forward, you're also driving forward and turning at the same time. So you can see the thing comes around, the heading of the vehicle starts moving like this until it's pointed at the goal. And that then once it is, so as soon as you get turned around, it says we're now 20 meters from the goal. As it starts moving forward, the lower left-hand plot says I'm getting closer and closer to the goal. And the one on the right simply says again, that's your offset from left to right of the center line of the robot, which is now pointed at your goal. So that's going to swing around, and that comes out to be 0. So if that makes sense, then we could go view what your actual data is doing. And it's probably, it's also going to be confusing because your vehicle is running off your odometry and then later switches to RTK. So that's going to be somewhat of a confusion there.
yeah, I mean, we can skip ahead to where it's got RTK.
And of course, it's going to screw up your plots on the bottom because they're they're just there to confuse you, I think.
So if I zoom in on this,
So go like right below, yeah, right about there. That'd be a good spot. I assume you have RTK data at that point. See, you had a little glitch on the right, on the green on the bottom. So I assume you're just right after the RTK kicked in. So now
correct.
at this point, we can say, looking at your plot, since your heading is going to be pointed kind of right, but it's pointed. I would think it should be pointed closer to the that goal point, the start of your path up there. I would think it should be pointed closer to that, but maybe just hasn't started controlling yet. So anyway, assuming that let's see, we don't have a convenient way to display the heading, do we? Like like an RViz, you can say, show me the transform, or show me an odometry or something.
I mean, I have um,
I just wanted to see it visually. I realize we can get numbers for it, but that's not going to tell us what we need to know. But so anyway, from that point, we should be able to predict. So if you since it's trying to get to the start point, it says you're on the right where it says a Y value of 5. That thinks that it's saying from the vehicle, if the vehicle's pointed we'll assume the vehicle's pointed along that path line that it's looking at right now. So we'll just use that as our marker reference. So it's saying from that point up to the start of the path, it thinks it's 5 meters, off that center line. So if you draw a center line straight out from the, let's see, I can't. We can't both poke it at the same time, can we? So if you assume the center line of the robot is that path where it's driving right there, so it's saying from there out the left side of the vehicle, which is where the our first goal point will be on on that path there. It thinks it's 5 meters off to the left of you right now, and that's kind of what that's showing us right there. And then as far as the distance on the left, it says, let's see what we got. We got from there to there is about 2. It's almost 3 meters away. That's that should be, as you get closer to the start of it, that should be reducing down, and it is, but it's always saying we're 2 meters away from anything. So I think that as it's bouncing up and down with the 2 meters, I think that says your look ahead is bouncing ahead every
Remember, the vehicle is turning hard left and hard right at this point. That's what this wiggly line suggests to me.
Well, but we haven't got that far yet. That's when it starts. See, we haven't even started controlling on the path yet, I don't think. So when we drive ahead a little farther and then it starts bouncing up and down, I think that's where it actually starts controlling. So it hasn't reached the first uh, pose point yet. And once it does, then it starts controlling, and you'll see on the left there, it starts, that's where it's kind of coming up. And then on the lower left, can you just zoom in a little bit on that so we can see? Yeah, right about there. Yeah, yeah, like that. So see, is it that first it's going down then going back up? That's as it's trying to align itself. And then you get over as that line starts coming down, probably about halfway down is where it picks up the first goal point and starts controlling. And then, yeah, as you say, it looks like it's bouncing back and forth at that point. So that's saying that's the distance between the vehicle and the next look ahead point, and that's why it's bouncing back and forth 2 meters at a time there. Because as you're driving forward and you get to the next pose point, it says bang, it jumps ahead one spot, which happens to be 2 meters, and that's why you're getting a really sharp sawtooth on that. Now the one on the right, it the very first path, it was going fairly straight up the path, isn't it? So that kind of shows you on the right there, it looks like that is controlling. It comes down and gets down close to 0, and it's not really, you can see it's waving back and forth a little bit, but not a lot. So that kind of explains that. So as it comes up, it gets close to the path. Can you stop it right there? And do we have a way to put to plot the look ahead on that top plot? If you'd also plot your, I think it was called look ahead 0 and 1, maybe is what the path. They'll plot the path, and I was just wondering, could we get the look ahead point to show up on that? I thought it was 0 and 1, but I'm not sure.
It is. Fantastic memory.
Yeah, zoom in on that area right there. And you might have to jiggle your slider on the bottom to get it to update. Okay, so now we can see, so if you back up the slider a little bit, and what's going to happen is that the look ahead point will disappear because we're not controlling yet. Okay, so what we want to do is, as it comes up to that bump and then starts coming back down on the red plot on the bottom, go up to that point.
Go up to that point. Tell me.
Go up that peak, that big peak here that's coming up.
You want to highlight this? No.
No, I just want to get your position set just to prove the point here. So right there, you can see where the orange dot is, and maybe the one on the top, if you can scroll that down just slightly, because we want to go the other way.
Maps. You wanted to see the red dot?
Yeah, I guess I'm gonna say the red dot and the orange dot. I didn't think the orange dot would show up. I think the orange dot shows up as soon as you publish the path. That's your
Yes,
first point, and that'll show up. So now what's going to happen here is as you advance forward, you'll see the red dot will start sliding up. And then when it starts controlling, all of a sudden you'll see the orange dot will jump ahead by 2 meters. And that's the red dots over here on the red plot. That's what that's doing there. So you're going to get closer and closer. Probably when it gets all the way to the bottom of that red point, that's when it will jump ahead by 2 meters. So I'm guessing the thing's actually controlling at this point and just watching for the next look ahead point. So right about now, it's going to jump. There, boom, it jumped up. So it says now we have a difference of 2 meters out the front of the vehicle. We're now 2 meters from that look ahead point we just selected. So now it's going to continue up, and when you get to the bottom peak again, it's going to jump ahead again. That's what that's doing. That's telling you. So that's your distance from where you are to where the next look ahead point is. And the stuff on the green on the right, I don't know what we
Yeah,
can
what's interesting
what we can
is,
glean out of that, but so
well,
again,
it's easy, but this is all zeros.
so again, that green is telling you on which side of the center line of the robot is the goal point. And if we had a way to plot the center line of the robot as it drives ahead, you could watch it. You should be able to watch it swinging back and forth. So the green line is telling you the error from the projected center line of the robot to our look ahead point. And so far things look like they're working right. It's kind of wandering back and forth more than it probably should, but it's still going relatively straight up the path there. Another thing, I don't think I've ever asked this. Have you ever verified that the robot is doing what you tell it to do? So if you take it out in the yard and say just I would say turn off pure pursuit, just don't start pure pursuit, and so point it some direction in the yard, either point it north or east or whatever direction you want, and go to your command line and do a ROS topic pub command velocity and put in your steer angle and a velocity and let it drive around a circle a couple times, and then come back and verify. If you tell it to turn at say 0.5 radians on the steering, does the resulting circle you generate match what you just told it?
Yeah, I haven't recently tried to do that. No. I mean, you just want to publish an Ackerman statement or a command velocity statement.
In your case, I believe you're running a command velocity, aren't you? Yes, you are, because you modified your pure pursuit to say jam the steering angle into that to turn your command velocity into a modified command velocity. So yeah, if you just publish that, that should just tell it. You're giving it a physical, you're specifying an actual angle. It's not on the joystick, you can move it back and forth, but here you can just say, I want it to turn at say 0.5 radians or whatever number you pick, and then let it drive around and then verify that that did what you expected that to do. Because if it's not doing what you're telling it, that's gonna confuse matters too. And I don't know how far it would have to be off for that to cause problems, but that could be a different issue that you would be having. It doesn't really answer why the steering would bang back and forth all the way, other than it's just trying wildly to correct for what it thinks. You tell it to turn so far, and it's either turning too sharply or it's not turning sharp enough. If it's not turning sharp enough, then that compounds. So the next time back around, it says, "Oh, we need to correct harder this time," and that's why it would oscillate back and forth, possibly. So that's just something you might want to check to verify that you tell it to turn at a certain angle to verify it's really doing that. I know you've got lots of calculations that tell you that, but it's always good to actually run it and then come back and see what it's telling you on that. And I had that script out in that directory I showed you that says something about rotational velocity and speed from ODOM or something like that. And if you just put that in and run it, that just constantly put out something called recovered, I think it says recovered radius and recovered steer angle. So just while it's running, then they would tell you, you tell it to turn at this rate, or you tell it to turn at this angle, and then what falls out the bottom, it says this is the angle it's actually turning. So that's something you could plot to see if those two are tracking each other. And this may not be anything at all, but that's something that's a fundamental thing you should check just to verify that what you're telling it is what it's really doing.
Yeah, that sounds like a reasonable test to do.
But that very first stuff we were looking at there that we're just now looking at, it looks like it is doing what it's supposed to do. It's just that then as you get up and turn around, then it starts getting more wild at that point. Because I assume the first time it went up that path and you said it was going fairly straight, if you watch the wheels at that point, are they staying fairly straight, or is it they wildly swinging back and forth even though it's going straight?
Yeah, at this point, um, I don't remember exactly what change it was, but no, the wheels do not stay straight anymore, even on the first pass.
Like, say for instance, on this plot we just looked at, would they have been fairly straight on that? Because it looked
Yes,
like it was doing a pretty good job at driving a straight line.
yes.
Now I forgot why I asked that. Oh, anyway, we're looking at those plots. Those plots look fairly good. Just that, coming up on the first point and there's a driving vertical, that all looked like it was doing what it's supposed to. Now I don't know why once you go up and turn around that it gets more wavy coming back. If you want something else to waste your time, if you have an extra web camera laying around, just stick it on the front of the vehicle and have it looking down so it can see your wheels. It can see if you had a mark on the ground so it knows the line's supposed to be, and just go into just plug the web camera in and go and fire up a ROS driver that says read the web camera, and maybe if you can say frames per second, set it down like 1 frame per second so it's taking snapshots, and just publish that. And that way when you play it back you can actually watch the wheels moving back and forth. And if you've got a line on the ground that you're trying to follow, then that would give you another indication. You come back and say, well, I can see, oh, it's turning like this or it's turning like that, as the thing drives along. So for each command it sends out, you can see how the thing's responding. Just a quick graphical representation of what it's doing, as opposed to trying to take all the different plots and figure out from this one to this one to this one what's it supposed to be doing. So that's just another thing that if you have an extra web camera laying around, you got a convenient way to mount it, that just give you more information on what the thing's doing. So when you play it back as a ROS bag, I think you can say somehow, well, maybe it won't do you any good. I know you can play it back with RViz, and RViz will show the show the image while it's driving around. So there you could say, go turn on your transforms and turn on this other stuff, and then turn on the image. So as you're driving along, you can see what, as the transforms are moving back and forth, and then plot out the, well, you can't plot it on RViz. Here's another question I was just thinking about. Somewhere in Plot Juggler it says you can plot real-time data. Have you ever got Plot Juggler to take data coming immediately out of the robot and plot it as you're driving along? I just wonder what that would take and if that is even possible. I don't know if it's possible with ROS, it might be possible with other things, but so it's kind of like watching.
Making sure it doesn't run over a tree or into a fence.
Yeah, yeah, you need a fence detector on your robot so you don't run into the fence. Yeah. So anyway, is that helpful, the stuff we just looked at? Or
Uh,
now that I know more about how to interpret those two transform plots we just looked at, maybe I'll run it and see if I can make more sense out of that. Another question is, are your, as you do bag files, are those stored out, say, like in your GitHub, so I can get a recent one as opposed to going back? Because the stuff I was running the other day was several days old on what I was running, and I don't know, what you've changed in between.
um, yeah, I store as many that I think are useful. I mean, there's no reason why I can't store more. Let's just see what's in my bag file directory at the moment. I think I got frustrated and like, none of this is worth keeping. Um,
So the thing is, if I go out to your GitHub and there's going to be a directory called bag files, if I just look there, I just grab whatever the newest one is, and that would be
I've
because
got the bag
otherwise,
files
Otherwise, you're putting links out in your Miro, and that's the only way I knew how to get your bag files. I click on that and download a bag file or whatever. But if they're just in a directory somewhere, I can just look through and say, oh, here's a fairly recent one. I can grab that. So
Yeah, I'll put them out in the Google because GitHub, I think, blows up like with 300 megabytes, and I'm looking at the gigabyte of bag files here. So
okay, that
in the Google Drive, there's a directory for field testing, I think. I'm just opening it up here. This directory called field testing, I generally put them into separate date folders. But if I look at the last one, let's see, that's Monday. Yep. So these are the 14th. I'll put another folder out for, well, that's the 6th, but these 3 are for the 14th. I'll upload those to oh, come on. Those will be out there in a second.
okay. So that's more stuff I can look at, and I'll, if I run out of stuff looking at it like that, I might go look at a simulator some more and see how I can modify that to do more fun stuff with that.
Yeah, if see, this is what's going to be fascinating is when you get yours running and it works perfectly. Why didn't that paste? Oh, there it goes. I just tried to put in the chat the Google Drive link. Yeah, I don't know. I'm just stabbing in the darks, but something has to do with the way that I'm creating the ODOM statement and the transform is screwing stuff up. And when you get yours working perfectly, I'll just be able to copy yours.
Yeah. Yeah, that I guess yeah, that's another thing I work on is finishing that off. I gotta generate the path and then copy the other computer and get the generate points thing and copied. And then theoretically I could go out and try to drive it and see if I bang into the house or into the fence, or we got a giant rock in the front yard. So lots of stuff I can run into. And the new neighbors put up a new little stupid fence out in the front yard. So it's always something.
Okay, turn off recording.
Okay.